Hi, everyone, and welcome to Module 1. We are going over the foundations of predictive analytics and an introduction to Python for data science. So each week, we are going to do one different module, slowly gaining knowledge towards those course learning objectives. So each week, it's going to seem like we're doing just a very small portion, but you're going to notice over time that you are gaining quite a bit of knowledge of predictive analytics, machine learning, all of the things you probably joined this program for. But I like to keep things pretty small. I try to keep lectures pretty short. The first week usually goes long because I'm chatty. But you will notice, like I said, that it's just one little piece at a time, and we're going to continuously add to it. So you will notice in this one, I'm going all the way back to the beginning. A lot of this is going to be review, probably from quite a while ago, and that's okay. My main objective for this week is that you get your technology set up, you feel good about the class, you get excited, you're ready, you do your readings. So this should be a breeze, and then maybe introduce a few new vocab terms so that next week when we come back, that module, you are so ready for it, and it's just a few new things we're adding. And then we continuously do that every week. So in this module, the foundations of predictive analytics. So like I said, we're going back to the beginning. And predictive analytics, we call it that very specifically to try to stay away from the term machine learning as much as possible. But at the core, we're talking about statistics, data, and analytics. So why statistics? What is data? How do we do analytics? We're going to go back to the beginning of that. We're going to review some common statistical methods. And if it's been a while since you've taken some stats classes, that's okay. I'm going to take you back all the way to the beginning to mean, median, and mode. And if you're still a little unsure as we go along in the semester, remember to go back to that boot camp. I created that to make sure that you had all of those statistical concepts and in little chunks. You don't need to have all of statistics memorized to do well in this class. Just know what you don't know and always be willing to ask those questions, do some extra research. We're going to unpack the term predictive analytics. Like I mentioned, we specifically did not call this class machine learning because that comes like a whole other can of worms. But in this day and age, it is machine learning. And we're also going to talk about the common applications in business. So why are you learning this and what are you going to do with it? And in the exercise video, you're going to go through the environment setup, Jupyter notebooks, and some basic analytical functions in Python. So it's not in this video, but I did just record it for the Python exercise. And I typically go through my lectures pretty fast. I provide all of these slides to you, and I expect that you would go back and read through the information if anything didn't make sense. A lot of my students still listen to this on 1.5 speed, 2 speed, whatever makes sense for you. And some of you might listen to this and then you want to go back in a few weeks because you're like, oh, wait, I don't remember that concept. Some of you are going to go through this first one with no problem, but maybe next week is going to be where you want a little bit more information. So my goal for this is that these lectures are relatively short and I provide a lot of other readings, videos, views from other people that might explain it in a slightly different way. But if you ever find that I'm not providing enough information so that you understand what we're doing, definitely reach out. I'm happy to go into more depth. But since this is a very large topic in 8 weeks, I'm trying to keep things pretty high level. Because with data science, you're going to find your niche. You're going to find things that are really interesting to you and dive in from there. And because a lot of you come from different backgrounds, I'm not going to do 8 weeks of statistics and scare you all too much. So don't worry. Like I said, we're starting at the very beginning with what is statistics. So statistics, we're talking about math, some type of math, obviously. But we're looking at the collection, analysis, and presentation of information/data, which we're going to get into what exactly that means in a minute. But what we want to do here is to be able to infer and induce information. We want to be able to understand what's going on. How can I use this information? Can I generalize things from this data? Can I better understand what's going on now? And we're going to use this so that we can do predictive analytics, which is then how can I forecast? How can I make a prediction of what's going to happen next? But we have to understand what's happening now. We have to be firm in what's going on right now before we really get into how can I predict the future. And again, this class is a super broad overview of a lot of these topics. There's no way I could cover everything in 8 weeks. I've tried to teach a statistics class in 8 weeks. I'm a stats nerd. There's so much to cover, and there's so many really interesting things. So I try to keep it to the things that are most important to you, but we're not going to get into things like hypothesis tests. So if that's something that you feel like you want a refresher on, I'm happy to provide resources. Basically, with statistics, when you're looking at how are they utilized in business, they are used all the time. It's just we don't always call them statistics. We're moving more towards calling them data analysis, data-driven decisions. Obviously, we want to talk about machine learning, AI, all of those things, but all of it is based in statistics. So some of the big ones, market research and advertising, it's all statistics. How can we generalize an entire population and understand what do people watch, what do people like, even though we're not getting to know individual people as well as maybe a single interview might? We're understanding a broad population and trying to generalize as much as possible. Think about the weather. Right now, I'm watching my poor neighbor try to shovel their driveway. How can we forecast better? How can we understand how much snow is going to happen? And is that going to freeze? And is Indianapolis going to plow our streets? And what's going to happen next after that? Sales, that's a big one. Obviously, in business, we want to make more money. So, who are our buyers? How do we sell more? Who are our users? And what are their habits? And how can we understand them? All of this is based in statistics. It's just not as fun to talk about statistics. We want to add some extra fancy things, but it's all in statistics. We are using statistics every day, even if you don't quite see it. And I think my picture's covering this up a little bit. One of my, again, statistics nerd, I honestly read this on my honeymoon. I love this book. It's called Naked Statistics by Charles Whelan. Highly recommend if you're not a stats person, but you want to start to understand statistics. It's written in a really great way. But as we start to get into statistics, we have to understand the context. And one of his examples early on is people who take short breaks at work are far more likely to die of cancer. And if you just present information like this, it's easy for other people to start saying, okay, we can't take breaks. We need longer work days. We need this and this and this. But context for statistics is so important because really, if you start to think about this, there's likely another variable that we're missing in this statement that's going to give us a little bit more information. And in this example, people who take short breaks at work, it turns out were the people that were taking smoke breaks. So people who take short breaks at work, people that smoke at work are far more likely to die of cancer because people who smoke are far more likely to get cancer. And if you get cancer, you're far more likely to die of cancer than people who do not smoke at all. So context is so important in statistics. So while everything is based in statistics that we're doing, almost everything is based in statistics, we have to remember that context piece. And that's one of the things I love about data science is that we're constantly looking at, yes, the numbers and the math and the data behind it. We also want to understand the people, the psychology, the behavior behind it. What's going on here and how can we better understand the data in terms of real people? And along those same lines, statistics are not perfect. As much as my undergrads want me to start sports betting because I'm a huge sports fan and I love math, I'm not a March Madness winner because not every team is going to win like they should. Someone's always going to have a bad day, or the refs call the wrong call, or someone gets injured or sick, or they choke, or whatever it is. The stock market doesn't behave like it's supposed to because it is a reflection of how we view stocks, not actually the inherent worth of companies. And there are so many examples of this. So statistics, while they are grounded in truth, they're not perfect. We still have to understand that humans are involved in a lot of this, and we are not rational people. So there's going to be some kind of funky things going on. As we talk about data and information, I sometimes use these interchangeably, but what we're really talking about, data is the raw, I hate to use the word information in the definition, but it's the raw values that we get. So raw observations, the raw measurements, information is what we get out of it. So data isn't anything to start, but as we contextualize data, as we add more information, as we transform it, as we make decisions from it, that's where it becomes valuable. And New York Times had a great quote: data is merely the raw material of knowledge. So I guess I teach this at the undergrad level, so you wouldn't have had me for this, but I always talk about how business intelligence is about turning data into information, into strategic action. So when we're talking about statistics, it's the same thing. We want to take those raw values, those raw, you can tell I'm trying not to say raw information, that raw data, the raw measurements. We want to turn that into information so that we can use it strategically. And that's where data scientists come in. We can't just run all of these through an algorithm and be done for the day, because we need you to actually understand the context and provide more context to it. And the reason why this is so important in a class like this is that if you're looking at analytics as a whole, yes, this class is about predictive analytics, and we'll get into prescriptive analytics as well. So what will happen in the future? How do we forecast? How do we predict? How do we understand what's happening next? And how can we make it happen? How do we, I always use the example of with COVID vaccines, we would predict the temperature of the COVID vaccines, and we would preemptively change temperatures and change different things to make sure everything stayed safe. To better do that, or to do that really at all, we have to spend some time here. So descriptive analytics and diagnostic analytics, that's really the bread and butter of data analytics, data science in general, and that's why we're spending an entire week of this class here. Really, most of your time here, and again, sorry, my picture's covering it up, 80% of a data scientist's time is spent in that descriptive analytics phase. I was on a podcast once, and it was just a few weeks into a new job, and the host was asking, okay, what kind of models have you made so far? And I was like, I just started. I haven't made anything. I'm looking at data. I'm understanding our business practices. I'm understanding our clients. And they kind of looked at me funny. And I said, if they wanted me to make a really bad model, I could make a model today. But to make a good model, to make predictive models, machine learning models, to make AI really what it's supposed to be, you have to understand what's going on. You have to understand the nuances, the context, the things going on within our data to make a good model. So your time is going to be spent here, and we're going to spend a lot of time here throughout this class, including this entire first week. So again, why are we discussing statistics? Descriptive statistics, remember that from maybe undergrad, maybe in high school. Descriptive statistics and descriptive analytics go hand in hand. If we're talking about descriptive analytics, what happened, what's going on with our data, we're going to start with those basic statistics. Let's maybe measures of central tendency, mean, median, and mode. What are my columns? How many values do I have? What's the average value? What's the median? What's the mode? So what's going on here? We're going to start here almost every time. So an example here, so I did have to change this since I just moved from Kansas City. So change this to the shop. If they've asked you to analyze their sales data, you're not going to start with a forecasting model. You're going to start with, tell me what you've what you've sold recently. So you might get some size options and orders, and you might start analyzing it. So looking at the mean, median, and mode, you might have some decisions here. So what's the average size? Maybe you'd calculate, do you assign a numerical value to size? Do you see how they're distributed? For mode, you can do that a little bit easier. You can look at, for orders, you can start, maybe if you had more data, you could start looking at how many t-shirts do people buy on average per order. Maybe you start looking at distributions, okay? As people order t-shirts, I can see in a visualization a little bit easier. Okay, the larges are a little bit more popular. It looks like, though, that my data is centered around that medium large. Maybe we'd change the distribution a little bit and start to look at what's the shape of the distribution, not just how many orders are in each size, but what's more of that shape. And that's where I'm getting at Where's the center of my distribution, that medium large? And so do I need an extra small, extra small? Do I need those larger sizes? We can start getting into, what does this distribution mean? Is it symmetrical? Is it skewed one way or the other? Is it bimodal? We talk about this a lot in education. We have those bimodal classes. We have a lot of people, a lot of students here at the lower end, and a lot of really, really great students, and then not quite so many in the middle. So how do we design a class that's meant for everybody? So these are those descriptive statistics. Again, I'm not going to go into too much detail on here. There's lots of resources on Brightspace and just in general. There's so many resources out there. We're not going to get into it in this week, but this is where you start with exploratory data analysis. What's going on? How do I understand the data? And then, as most of you have taken either Tableau with me, the spreadsheet class. For some of you, this is your first class. But start to think of some of the questions you've answered, even though we're using Python. What questions have you answered with other tools? So if you had this data in Excel, maybe you would start filtering by size. Maybe you would start by making a pivot table, pivot chart. We're going to do those exact same things here, just in a different tool. We might start to look at variability. So the measures of central tendency are, where is my data kind of centered, but how does it spread? Where are the outliers? Where is the variation in my data? What's the range? And from here, we can start going into inferential statistics. So we can start understanding maybe a general population. So is all of Indianapolis centered in the medium-large range, or does the shop cater to a specific size of person? We can start to understand how confident we can be in that data based on the statistics that we have. We can compare across variables. We can do hypothesis testing. And again, an example, because we're not going to do hypothesis testing in this class, but maybe we work for a company that produces cereal, and we want cereal boxes to be 18 ounces because we said they have 18 ounces. We should deliver what we promise. How do we actually test that? We would get a random sample. We would calculate the sample average. We would determine the probability that the population is the same as the sample. And then we conclude if the actual population is greater than or less than the sample. So instead of testing every single cereal box, just like instead of asking every single person in the world, what t-shirt size do you wear, we can start making inferences from a smaller sample size. We'll also talk a little bit about significance and probability a little bit next week, but not too much in this class. But remember those p-values, the probability less than 0.05. Are we going to support or reject a null hypothesis? Are we going to be able to say that our cereal boxes are 18 ounces like we said they are, or are we overfilling them? Are we underfilling them? So as I go through all of these things, the difference you might start to see between this kind of class and a traditional statistics class is that in traditional statistics, we are really basing a lot of things on these sample data sets, drawing a representative sample from a larger population, because that's how it is in statistics. We can't measure every single cereal box. We can't do those things. In modern statistics, though, modern data analysis, we don't do as much of that because we often have a ton of data that we actually can use. So I'm not saying we won't take samples of our data, but we actually have more data and we don't have to collect it ourselves like in traditional statistics. So when you go out and work for a company that has data, we're not often having to actually go out and collect and observe data ourselves, write it down, put it somewhere, and then test hypotheses. It's usually stored in a database for us. It's stored somewhere. We can run our statistics and start modeling right away. So that's kind of the benefit of the modern statistics, is that a lot of modern statisticians are actually data scientists because we don't have to do a lot of the traditional statistics. Not that they've gone away, but they've just evolved into what's now known as data science. As we get into predictive analytics and machine learning, I just want to lay out some quick vocabulary. And this nightmare is what's really going on in the industry right now, and this continues to shift. Um, when we talk about predictive analytics, it really encompasses all of this. Data mining is in here, statistics, machine learning, AI. When we're talking about these terms, I try to stick to predictive analytics. We are doing analytics, so we are understanding data, we're turning data into information, and we're sticking with that predictive because we are going to try to forecast. We're going to try to predict what's happening next. As you get into machine learning and AI, it's a little bit of a sticky spot, especially today with all of the AI tools. People kind of call everything AI. But in general, what they're talking about is that machine learning, AI, we are trying to emulate the brain. So we are trying to make new connections without actually teaching the machine anything. So if you think about like ChatGPT, that is more of AI. That's actual simulated thinking versus what we are doing, which is true predictive analytics and really getting into machine learning. It's not quite AI. Some people will call it AI though. A lot of it's pattern recognition, neurocomputing is all in here. The basics is we're doing predictive analytics. We're slowly getting into machine learning. Some of it may be considered AI. The big thing here is that there are a lot of buzzwords in the industry. So as you look into some of the things we're doing, ask yourself, what data are we using and what are we trying to do with it? Are we predicting something that has happened? Are we looking at what happened in the past? Are we generating new ideas? That will tell you kind of where we're laying here. But like I said, in general, machine learning, we are training a model, so an algorithm, a set of rules, and we are trying to generalize a decision against a performance measure. So we want to create some sort of rule that's going to find a pattern in the data if it exists. And this pattern isn't easily identified by the human eye, and that's why we use machines to do it. They can find it a lot easier than we can. We've worked with the machines to help figure out different algorithms that work best for different data. But the trick here is that the pattern has to exist. There has to be an actual pattern, or machine learning doesn't work. So you will often find that machine learning projects fail about 80% of the time in business. And that's normal. That is why a lot of businesses are actually struggling right now because they want to invest resources in data science, data analytics, but they're not willing to invest in research and development. They're not willing to invest in projects that are not going to succeed every single time. Machine learning is not guaranteed to succeed if there's not a pattern in the data. If you are selling something and your users are just kind of all over the place and there's no pattern yet, we can't create a pattern out of nothing. There are two main types of predictive analytics that we're going to talk about. The first, 3 weeks, I think, are about supervised machine learning. And this is where the data is labeled and we are aiming to predict something specific. And when I say data is labeled, it's that we have past data that has indicated in some way what we're trying to predict. So for example, if we're trying to predict if a basketball team is going to win or lose, we have previous data saying that these teams have won and lost before. We've got data to tell us what has happened before because the machine is going to learn from that. In unsupervised machine learning, there are patterns in the data and we're using different algorithms to come up with those patterns, but we're not predicting a specific column in the data set. So rather than predicting, is this team going to win or lose, we might try to group basketball teams together. In general, supervised learning works by taking a data set and splitting it into two. So we're going to take a training data set, and that's what we're going to learn from. And we're going to take a test data set, and we're not going to look at it yet. There are different ways people split this up, 80-20, 50-50, 70-30. We're going to try out a lot of different ways so you can see what happens when we take these different splits. So that's coming in a different week. And with that training data, we're going to create a model, and we're going to create that training model. That training model is then going to test itself in the test data. So it hasn't seen this new data before, and it's going to say, okay, I created these set of rules. Do these rules work? If they do, great, you have a predictive model. If they don't work, you might retrain the model. You might resplit it up. You might try some other things. Again, you might find that the pattern doesn't exist. And if it works, you have a predictive model. Again, super general. We'll go into more specifics next week. And this is a graphic I just like. We're taking that raw data, we're creating an algorithm, and it's called supervised learning because you are the supervisor. You are splitting up the training data set. You are telling the machine, this is my desired output. This is the column I'm predicting. This is the value I'm predicting. It's going to process and it's going to create that output. It's going to predict a specific value. And that specific value can be a classification model, so a category, predicting male or female, upper, middle, lower, buy or not buy. One really common one is churn modeling. So are you going to stick with your current cell provider or are you going to leave for a different company? There's also regression modeling, which we're going to do next week. And that is what's the value of X. So if you've ever done linear regression, so Y equals MX plus B, we're going to go back to that next week. Gas prices. What is the gas price going to be next week? What is the age of this consumer based on all of their purchases? How many items are they going to buy based on all of these factors? How many inches of snow are we going to get based on our latitude and longitude, the humidity in the air, the temperature, all of these different things? So regression, we're trying to predict a specific numeric value. And we're trying, typically in a regression, we have a line that we're going to create in linear regression. In classification, we want to look at the category. In unsupervised learning, we've got that raw data. And you notice there's not a supervisor there because you are not supervising it as much. You're still involved, but you're letting the model kind of do its thing. And if this doesn't make sense yet, don't worry, we're going to spend a lot more time on it. You don't know the output yet, and there's no training data set. You're giving the algorithm the entire data set, and you're letting it find these patterns. So a common one is finding patterns in user data and figuring out different subsets of marketing groups that you can market to. So you might find that if we're looking at churn modeling, we can also look at unsupervised learning and say, okay, people that stick with their cell provider, there are people that upgrade their phone every year, and there are other people that are on family plans and some that they have really old phones and call into customer service a lot. So I didn't tell the computer, the machine, to predict, are they on a brand new cell phone plan? I gave it all the information and it found the patterns from there. Again, we'll go into more detail soon. So some common applications, that churn modeling I mentioned. K means clustering, so what market segments exist within our customer base. Association rules, if a customer buys product A, what else are they likely to buy? So if a customer is going to buy diapers, what we've learned is that the next thing that they might buy at the grocery store is beer. So that's why you'll often see that diapers and beer, sometimes they try to put them kind of close together, and sometimes they try to put them on opposite sides of the grocery store to get you to go through the entire grocery store. You can see this at sporting events. So if you buy a hot dog, they'll put like a free drink coupon because they know you're going to want a drink and you're willing to get something for it. So this is where a lot of marketing gets really interesting, is that they know the patterns that exist. So they try to capitalize off of that and say, how can we get them to either buy products they wouldn't normally buy or buy more of the products we know they already want? So that is the end of lecture 1. Tasks for this week: complete the required learning activities, participate in the discussion board, which is really that slide. You make your own slide, introduce yourself. Homework number 1, you're actually not completing it, you're just starting on it. And then get your Python environment set up. And I forgot to put, there's also a quiz, just 10 questions, 9 questions. Anyway, 20 points, and you can take it twice. So I will just keep your best score. With that, have a fantastic week, and I will see you next time. Bye.